प्रॉपर्टीज मेंशन्ड इन अ ब्लड टेस्ट आर ऑल इंटेंसिव। ये क्यों कह रहा है इंटेंसिव है? क्योंकि ब्लड टेस्ट जो हम कराते हैं तो वो एक छोटा सा सैंपल लेता है, उसी से वो सारे कुछ बता देता है हमें, उसी से वो हमें सारी जानकारी दे देता है। तो ऑब्वियसली अगर वो मास पे डिपेंड कर रहा होता तो उस छोटे से सैंपल में, क्या होता, सैंपल में सारी जानकारी नहीं आ सकती थी। लेकिन अगर एक सैंपल से लेके हम सारी क्या कर रहे हैं, सारी जानकारी अगर किसी को बता दे रहे हैं, तो ऑब्वियसली दैट पर्टिकुलर प्रॉपर्टीज और वॉट एवर इंफॉर्मेशन द ब्लड टेस्ट गिव्स अस, दे आर ऑल इंटेंसिव प्रॉपर्टीज। फाइन। तो हम देख रहे थे कि इंटेंसिव और एक्सटेंसिव प्रॉपर्टीज़ को डिस्टिंग्विश कैसे किया जाए। तो यदि कोई एक सिस्टम गिवन है, उसके वेरियस सारे प्रॉपर्टीज़ हमें अगर पता है, से प्रेशर, इंटरनल एनर्जी, टेम्परेचर, डेंसिटी वगैरह वगैरह, ये सब अगर हमको पता है, और हमें पता ये करना है कि उनमें से कौन सी प्रॉपर्टी इंटेंसिव है, कौन सी एक्सटेंसिव है, तो हम करेंगे क्या, हम उस पूरे सिस्टम को दो इक्वल पार्ट्स में डिवाइड कर देंगे, या मतलब एक उसमें दो पार्ट्स में उसको डिवाइड कर देंगे। उससे होगा ये कि जिस भी प्रॉपर्टीज़ की मैग्नीट्यूड जो है वो अगर चेंज कर जाती है, वैल्यू अगर उसकी चेंज कर जाती है, तो दैट विल बिकम एक्सटेंसिव प्रॉपर्टीज़। और जो प्रॉपर्टी हमारी अनचेंज्ड रह जाती है वो हमारी क्या हो जाएगी, वो हमारी इंटेंसिव प्रॉपर्टी हो जाएगी। अब इसके बाद हम बात करते हैं किसकी, वर्क और हीट की। बेसिकली क्या है कि हम प्रॉपर्टीज़ की जिक्र कर रहे थे। प्रॉपर्टीज़ आर द कैरेक्टरिस्टिक्स ऑफ अ सिस्टम विच हेल्प्स अस टू डिफाइन द स्टेट ऑफ द सिस्टम, इजंट इट। लेकिन वर्क और हीट ऐसा नहीं है। वर्क और हीट जो है वो सिस्टम की प्रॉपर्टी नहीं होती है, ये बात समझो। वर्क एंड हीट आर energy in transit, they are what, they are energy in transit। अगर इसकी हम बात करें तो they are energy in transit। सो हमने क्या देखा है, हमने देखा है कि हीट और वर्क एनर्जी के फॉर्म्स नहीं हैं, बल्कि these are the names given to the method through which energy interaction has occurred between two states। अब समझो हम क्यों कह रहे हैं कि हीट और वर्क, या ऐसा हम क्यों कहते हैं कि हीट एंड वर्क आर एनर्जी इन ट्रांजिट। ये दीज आर नॉट द फॉर्म्स ऑफ एनर्जी, वर्क इज नॉट अ फॉर्म ऑफ एनर्जी, या हीट इज नॉट अ फॉर्म ऑफ एनर्जी, नहीं। ये क्या है, दीज आर द मोड ऑफ एनर्जी ट्रांसफर। यदि सिस्टम एक स्टेट से दूसरे स्टेट में गया है, समझो इस चीज़ को, यदि सिस्टम एक स्टेट से दूसरे स्टेट में गया है, सपोज करते हैं कि यहाँ पे इनिशियली हमारा सिस्टम यहाँ था, इसमें कुछ प्रॉपर्टीज़ में चेंज आ गई, ऐसा हुआ है, इसमें कुछ एनर्जी इंटरेक्शन हुआ या कुछ मास इंटरेक्ट हो रहा है सिस्टम का, ठीक है। सिस्टम और सराउंडिंग के बीच में जो इंटरेक्शन है, आइदर इट इज़ इन टर्म्स ऑफ मास और इट इज़ इन टर्म्स ऑफ energy। So what is happening, certain properties of the system are getting changed. Due to change in property, what we say that the state of the system has changed, because what was the definition of property? Properties are the characteristic of a system which helps us to define what, which helps us to define the state of the system, जो हमें सिस्टम की स्टेट को डिफाइन करने में मदद करता है। अब यदि प्रॉपर्टी ही चेंज हो जा रही है तो स्टेट ही चेंज हो जा रहा है, सिस्टम का स्टेट ही चेंज हो जा रहा है ना। तो वही हम कह रहे हैं कि इनिशियली सपोज करो कि वो पहले 1 पे था, इनिशियली द सिस्टम वाज एट 1, ड्यू टू certain interaction of energy or certain interaction of mass, whatever may be the case, at this point of time we just need to know that there is certain interaction occurring between system and surrounding, जिसके कारण हो क्या रहा है कि सिस्टम की प्रॉपर्टी चेंज हो रही है। सिस्टम की प्रॉपर्टी चेंज हो रही है तो उसकी प्रॉपर्टी इनिशियली कुछ और थी, मीन्स टू से वो इनिशियली किसी एक पर्टिकुलर स्टेट पे था। ड्यू टू द इंटरेक्शन अकरिंग विद इन द सिस्टम and the surrounding, the properties are getting changed, so there is a change in state of the system, so there is a change in the state of the system, let this point be 2। So ultimately what is happening, system is traveling from state 1 to state 2, is traveling from state 1 to state 2, isn't it? So we say that if there had been some energy interaction, it may have occurred in form of heat, it may have occurred in form of work। Are you getting my point? what I'm trying to say, heat and work, they are not what, they are not the properties of the system. वो system की property नहीं है. These are merely the mode of energy interaction. These are merely the mode of energy interactions, or it is the mode through which energy interaction can occur between the system and the surrounding. That's it. That's it. So, you see, whenever the system is at any particular state, whenever system, until and unless, whenever or until the system was at this fixed state 1, were we talking about how much work is here at this particular state, or how much heat was there at this particular state? No, we do not talk about heat and work whenever the system is stationary at any particular state. Are you getting my point? But we can talk about that what is the temperature of the system when at this state. What is the volume of the system when is it at this stage? Isn't it? So this is the meaning of property. Property, whenever the system is at any particular state, you can talk about the magnitude of any property. But since heat and work, they are not the property of the system, so you cannot ask me or you cannot ask anyone or you cannot question anyone that what is the amount of heat when the system is at this state, what is the amount of work when the system is at this state. Are you getting my point? This heat and work you can talk about only when the system is changing its state. Whenever the system is changing its state, only then you can ask about what is the amount of work, what is the amount of heat. Are you getting my point? So this is what we have written here. If you gonna rotate it, you will see. If you rotate this a bit, I let me see that if I can. Page action is here. Let me just see if I could. No, pardon, I'm absolutely sorry. I cannot rotate this page. If you could just turn a bit, turn your mobile by 90 degree, you could easily read out whatever I have written here. This is merely a kind of concept that is written here, that हमने देखा कि heat और work energy के form नहीं है, बल्कि these are the names given to the method through which energy interaction has occurred between two states. मतलब किसी स्टेट पे हीट कितना है या वर्क कितना है, ये पूछना गलत होगा. हम ये पूछ सकते हैं कि एक स्टेट से दूसरे स्टेट जाने में हीट इंटरैक्शन कितना हुआ है, या व्हाट परसेंट ऑफ द हीट इंटरैक्शन हैज़ अकर्ड एज हीट. सिमिलरली किसी स्टेट पे वर्क कितना है यह पूछना भी गलत होगा. रेदर हम ये पूछ सकते हैं कि व्हाट परसेंट ऑफ एनर्जी इंटरैक्शन हैज़ अकर्ड एज वर्क, या व्हाट इज द वर्क इंटरैक्शन ड्यूरिंग द प्रोसेस. सो यू सी, whenever the energy interaction is occurring between system and surrounding, leave mass side for a second. Fine. Let's concentrate on the energy interaction whatever is occurring between the system and the surrounding. So whenever there is a interaction of energy between the system and surrounding, so both heat and work, they both are the modes of energy interaction only. So out of total energy interaction, some portion of the energy interaction can occur in form of work, some portion of energy interaction can occur in form of heat. Are you getting my point? Are you getting my point, what I'm trying to say? It may happen depending upon what? Depending upon your process that your system is undergoing, you can have a larger portion of the energy interaction occurring in form of heat, no portion of energy interaction occurring in form of heat, entire energy interaction occurring in form of work, no portion of energy interaction occurring in form of work. This proportion of energy interaction, either in form of work, either in form of heat, this may change depending upon the type of process your system is undergoing. Fine. So what could be the right way to ask question? You can ask that what percentage, what proportion, or what part of the energy interaction during a process is in form of heat, or what is the heat interaction during this process. So what ultimately I'm trying to make point out of it is, we talk about work and heat only when there is a transition of state, only when your system is in transition, it is changing from one state to another, and not when it is stationary. So you might get to see a very prevalent statement in almost every book on thermodynamics. They write work and heat are energy in transit. Work and heat are energy in transit. Fine. So this was, I think, this much discussion on heat and work is fine for your understanding, or you can say is enough for your understanding, isn't it? So this was all. So there is a uh, few differentiation that we have made between the properties and heat and work. So we discussed everything, whatever is written here, we discussed everything here. So we will quickly review the points. So what is property and what is work? Fine. So work and heat, the energy transferred in form of force is work. Energy interaction which is occurring in form of force is called what? Is called work. We will see a detailed discussion on. For the time being, you just understand one thing, that whatever energy transfer is occurring in the form of force, फोर्स के फॉर्म में जो भी एनर्जी का ट्रांसफर हो रहा है, दैट इज कॉल्ड वर्क. फाइन. प्रॉपर्टीज. सो प्रॉपर्टीज आर पॉइंट और स्टेट फंक्शन. क्या मतलब हुआ इसका? हम देख रहे थे ना कि किसी स्टेट पे हम प्रॉपर्टीज़ के वैल्यू की बात कर सकते हैं. सो ये प्रॉपर्टीज़ आर डिफाइंड एट द पॉइंट्स. Heat and work, they are energy in transit. Whenever there is a transition occurring place, whenever there is a path, as you go on changing the path between the system, you will get different magnitudes of work, different magnitudes of heat. So they are what? They are path functions. Properties are point functions. Properties are independent of the past history. Independent of the past history means whenever the system is at any particular state, whenever the system is at any particular state, and you ask that what is the property of, what is the magnitude of certain properties or this property at this particular state, you need not to take into consideration that what was the magnitude of that particular property when the system was when the system was earlier at some other state, or what was its magnitude at the state from which the system has come to this state now. No, you need not to take that into consideration. At every point, at every state, the system will have a peculiar or a specific magnitude, specific value of different properties associated with it. So they are independent of the past history. You need not to know that what was the state, what was the condition of the system prior to this state. Fine. Now second thing, dependent on past history. Work and heat are dependent on past history. What does this point means? This point means that work, heat, they are dependent on past history. Means they are dependent on path being followed. past history means, say, if instead of this state, if the system would have been at this state, so obviously when the system reach, or when the system goes from this state to this particular state, so obviously this path will be shorter one, isn't it? So what I mean to say, that the location of previous state or the previous state is somewhere determining the path which the system may take from going from one state to another, isn't it? If this state would have been here, then there would have been infinitely, in fact between any two states there is infinite way for the system to travel from this particular state to another. But what point I'm trying to make out is that it is the state that is somewhere determining the possible paths available for the system, and path is the one which is determining that what could be the magnitude of heat and work. So since heat and work is a path function and path is depending upon the state, so the past history becomes important to take into consideration, that where the system was or from where the system is coming, isn't it? As in today's time of corona, if you are smiling, if you have if you have gone to your relative's home and you are smiling, say, if you greeted them with a good gesture, if you are smiling, they would simply smile back, isn't it? Okay, what I'm trying to say is, it may not be relevant here, but still, um, allow me to connect. That is, that your smiling face conveys them that okay, you are in a good health. So you being in a good health, going to a relative's home, this would not make them, or this would not have been, or earlier this could not have been a point of concern for your relatives to ponder that from where you are coming, isn't it? Your past history was not required for them to greet you. But in today's uncertain times, whenever you go to your relative's house, it becomes, even when you go to your own house also, your past history becomes very important, that what places you are coming through after visiting, what places have you been to visit, and from where you are returning, have you been in contact with someone covid positive. So try to connect it that way, only then you can retain certain things for a long period of time. So work is dependent on path, work is dependent on path, and it depends on your past history, it depends on your past history. Now see, exact differentiation, whenever you integrate certain things from 1 to 2, you integrate, you write the value, say dt, integration of dt will be t, you write the value, say, if integration of dt, we know that the integration is 1, and if the integration is from 1 to 2, we do what, we write the values of this temperature at state 1 and at state 2, isn't it? So writing, so for a point, for the property, we can write this, because we can write the values of the properties as state 1 and the properties and the value of properties as state 2, because properties are point function, they are defined on every point, so they can be written in terms of differentiation, so they are exact differential. If you write any property like this, you are going to get exact values at different states. These are states, these are nothing but states. So you are going to get exact values of properties at each and every state, and therefore you can write them in differential form. This is what this exact differential means. So this you can write only for a property, but can you write so for a work and heat, or anything that is not a property, or anything that is not defined at every point? And even if it is defined, you don't know that what is the value at that particular state or that particular point of that particular thing. So in that case, you cannot write. So you cannot write like this, that integration of, you can write integration of del work, fine, but you cannot provide a limit here. And even if you're providing limit, you cannot write like this, right? Not every time this comes to be equal. Not every time this LHS will become equal to the RHS. Are you getting my point? So this is what I'm trying to make out of it, is that it is inexact, work and heat are inexact, properties are exact differential. This was the basic three, and in fact these properties are very much exploited by the, from the gate point of view, that they can ask you that which of the following are the associated with properties, what statements regarding properties are true. So you need to keep these things in mind, that whatever properties we are talking about, they are point functions, they are independent of the past history. Past history is not a matter of concern in case of property. Exact differential, they are exact differential, and reverse of all this is what we have for heat and work. Heat and work are path functions, they are dependent on past history, they are inexact differential, they are inexact differential। सिस्टम के एक पर्टिकुलर स्टेट पे हम उसकी प्रॉपर्टीज़ को मेजर कर सकते हैं। इसके लिए हमें ये जानने की ज़रूरत नहीं है कि सिस्टम उस स्टेट पे लाया कैसे गया है। Therefore we say that property does not depends on path and thus is independent of the past history, right?